I am Amber Motley. I am the Senior Manager of the Short-Term Forecasting Team for the California ISO, and I'm very excited to be here to talk more about the operational pieces that are going on. Specifically for this presentation, I'll focus on the behind-the-meter solar impact to demand and operations. Next slide. So a little bit of what we'll walk through, a very quick CAISO overview. I know you guys have talked about CAISO and the EIM in some previous of the training presentations. So I'll just touch on that a little bit and then go into the expected growth of the behind the meter penetration, overall, how the demand forecasting is working at the California ISO, and the operational impacts that we've observed from behind the meter penetration. Next slide. Just a few facts. CAISO is one of the 9 ISO RTOs in North America. We're on the far western side and we cover California and a little bit of Nevada as the grid operator. We have a peak load of 50,270, which was set in 2006, but we also got very close to that peak load in 2019 as well as in 2020. We did see a lot of conservation flex alert that kept us underneath the 50,270 level, but we do see in the last 2 years as well. Next slide. On top of operating the grid as the bulk system for California and a little bit of Nevada, we also have the Western Energy Imbalance Market. It launched in 2014 with Pacific Corp, both West and East being the first EIM participants. And since then, you can see that it has grown to much of the Western United States. We have welcomed recently Northwest Energy last week. So even though I submitted my slides a few weeks ago, they have now joined the EIM and are participating within the EIM market. It has seen gross benefits exceeding $1 billion. We hit that mark last year and reduced over 500,000 metric tons of CO2 emissions. Next slide. Now diving into a little bit more of the topic and behind the meter. The California Energy Commission, or CEC, puts out, and I know in the previous slide that Ryan had, he was showing the different projections that the CEC has with the high, the mid, and the low case for behind the meter growth. And this is coming from that same database for the CAISO system in specific, and looking at the growth 2021 for rooftop all the way through 2030. Now note, this is the production that's expected. This isn't the capacity. This is the production that we will see on the system during those period of time. So the production by 2030, you see 18,741 megawatts entering the system. There's also a map to the right that kind of shows the concentration of the capacity in its current state, showing where a lot of it's heavy Southern California, you know, some of the areas that are inland, which do correlate to where our large scale solar exists as well. But we also have a large penetration now down in the southern San Joaquin Valley, you know, near the Fresno areas. You see that area lighted up as well. Rooftop solar, as you guys know, is not connected to the high voltage system, but it definitely has an impact to the market and the grid operation. And we're expected to see, you know, around 19,000 megawatts by 2023. That's getting close to the capacity sizes that we have on solar on the high voltage transmission connected system. So we are getting very close to seeing the same amount of penetration behind the meter as we see on the high voltage transmission system. Next slide. So this walks through a little bit about what's going on behind the scenes of load forecasting or demand forecasting in the CAISO. So I'm not going to walk through each component, but one of the things I wanted to highlight is we produce forecasts day ahead that go out 9 days. Those are in hourly granularity. And then we produce real-time forecasts that are 5-minute granularity for a rolling 24 hours. That's something that gets updated continuously over time. The big inputs that are going into there that have recently changed for the California ISO within the last 5 years is we have a behind the meter forecast provider that is an input into the weather models and the demand model, just like temperature is. We have 2 weather providers that provide temperature, wind speed, wind direction, humidity, and those variables that also go into the load model. We have a meteorological review of these conditions internally. We have meteorologists on this short-term forecasting team. but we also are inputting into the models behind the meter actuals, which are coming from a subset of the inverters throughout the state of California. So we actually are reading from an inverter company that has 30% of the share of California's rooftop solar systems, and then aggregating them up into the regions that we forecast on the system. And those forecasts you see on today's Outlook, there's a few graphs that show the different forecasts. They're used in the RUC, the Reliability Unit Commitment process, which is done in the day-ahead time frame, out 3 days. Outage coordination, next day studies, and then the real-time forecast is used in the real-time market optimization to form the commitment decisions and pricing that exists. In addition to that, the forecasting team also provides confidence bands. The more renewable penetration that you have on the system, the more weather error that may be present, same with temperature error. So we started providing our operations team confidence bands that are not just solely based off of statistics, but are based on the weather error that we will see, whether it's behind the meter weather error with cloud cover, or if it's temperature error driving some of the load forecast. Next slide.
Amber, you've got 5 more minutes.
Oh my goodness. All right, well, these are the historical load shapes going through the different pieces. You see that the historical load overall, this is an average of every day in March. You can see how that's changed the energy demand over the different period of time that we're forecasting. This impacts the different forecasting components and all of your historical data that's training your models. And you can see overall, the demand now looks very much like net demand. Next slide. So demand forecasting with increased behind the meter solar. You see increased movement in forecast updates, and I have a different slide that will talk about that. You see a more present weekday versus weekend impact with behind the meter on the system. Your morning peak is very sharp and turns very quickly the larger penetration that you have on the system. And it is right during that sunrise time period. And then in addition, one of the things that we've taken into consideration for planning as well as short-term forecasting is the peak time shift, the evening peak time shift. We've seen over time, we may have peaked at 12 or 13 in the middle of the day during the summertime, but that's definitely pushed back with the increased penetration of behind the meter solar. You've needed new modeling methodologies to do demand forecasting. And then there is forecast error degradation that's occurring because you have a very variable resource underneath that demand forecast. And I have a slide on that too. Next slide. This is an illustration, and you can see on the right side, it's a load. There was a cloud system moving through the San Diego area for this particular day in June. And you see that as that cloud, we knew it was going to be cloudy that day, there was a small break in the cloud. It moved San Diego's load 500 megawatts in 30 minutes to an hour. This is a real impact of having concentrated behind the meter solar on a system. Next slide. This is the slide I was talking about in relation to demand forecast movement. I'm just going to focus on the lines on the left side when you're looking at the morning peak. So on the far left side, you see the graph of the load forecast movement. On the right side, you see the graph of the behind the meter forecast movement. The load forecast movement is happening in this case. The area had a heavy penetration of marine layer behind the meter impact. You saw load takeoff, and the load, every single blue line that you see on here is the load forecast updating based on the behind the meter solar as an input, and then based on the behind the meter solar coming in as well as where the actuals are trending, it's going to update and try to correct for it. We have been monitoring the movement on the system of all the updates, but you can see that this is something that happens. You see more movement. You see when in your updates of your load forecast, they can be more extreme when you have high penetrations of behind the meter solar on the system. Next slide. This is a look at the forecast accuracy. On the left is day ahead load forecast accuracy, but I wanted to put underlying it is our behind the meter forecast accuracy. We made some enhancements in 2020, which is why you see very big differences between 2019 and 2020 on the day ahead behind the meter forecast error. But The behind the meter forecast error, even with the changes in 2020, run around 15 to 10%, 5% on a good time for when you look at MAPE, which is forecast minus actual divided by the full sun that happens during that month. On the left side, that impacts overall your day ahead load forecast error. It's embedded in that error. We've noticed trends that Q1, which is our cloudy period in California, as well as Q4 run the higher error when we have behind the meter. This past year, we didn't have very many clouds. We did not get very much rain, so you can definitely see that it wasn't as impacted in 2020 as in previous years, but you do see March of 2019, March of 2020 having larger error, a lot of it driven from the cloud cover that's moving through. Next slide. And then I think I have 2 left. Operational impacts overall, just high level cover the different operational impacts. The need for flexibility. You see how much the load forecast movement is happening. You have behind the meter there that is moving. The marine layer is coming in and out. You have cloud cover that is coming out. There's flexibility needed on the demand forecast, as well as the renewable penetration that sits on the system on the high transmission voltage. Changes in the methodology for regulation requirements. We've changed our regulation requirement methodology to look at impacts of what we call net load. Net load in the CAISO definition is the load that we're serving minus renewables, so wind and solar that is grid connected. More granularity needed on the load side for optimization. So we recently, in the last 3 years, we used to forecast California ISO as a whole in 3 regions. We now broke that into 6 different regions because we needed that granularity for the optimization of the market. You have added uncertainty in the system. And then because all those different pieces are happening, you do see impacts on the ACE and the CPS1 scores that we have to monitor very closely going forward. Next slide. And this is my last slide. This is just some of the different components that we've been working on to advance high penetrations of renewable resources. One of those, of course, being behind the meter solar. I won't go through each one of them, but the most important one to talk about with behind the meter solar is the integration of a behind the meter forecast, and more importantly, a behind the meter actual provider that feeds your demand forecast instantaneous. We get updates from our behind the meter forecast every 5 minutes, and we get updates on the behind the meter actuals as well every 5 minutes going into those forecasts. And the other one I'll point out is on the far left, NWP, gotta love acronyms, numerical weather prediction models. We are now taking a lot of the weather prediction models that are provided from NOAA are free. You can take those and bring them in. So we are taking that information and key data points, whether it be a global horizontal irradiance or temperature, and we're inputting them directly into our demand forecasting system to be another vendor, right? We have 2 weather vendors, but we're also adding the direct input of the numerical weather prediction models now into our demand forecasting. And with that, I know that was a lot, I talked fast, but I will pass it back.